Hi everyone, in this video we are going to see how to find the joint equation of tangents drawn from an external point for a circle. In the previous video I have discussed about how to find the equations by deriving the slope of each of the tangent lines, and in this video we are going to see how to find the joint equation of both tangents, and from the joint equation of course we will see how to find out the individual equations of the tangent lines. Let's suppose we have a circle like this whose equation is x squared plus y squared plus 2gx plus 2fy plus c equals 0. Obviously the coordinates of the center would be negative g comma negative f, and the radius will be square root of g squared plus f squared minus c. And let's suppose we have an external point P whose coordinates are x sub 1 comma y sub 1, and we have drawn two tangents from the point P onto the circle. PA is one of them and PB is the other one. So A and B are the points of contact. Next, if we join C with A, then CA will represent the radius of the circle. Let's denote that with a lowercase r. Now I am going to take an arbitrary point on the first tangent line. Let's say the point is Q, whose coordinates are A comma B, and then somehow I am going to create an equation for the locus of this point. And once we are able to derive the equation of the locus of this point Q, then that will be the joint equation for both the tangent lines. In fact, it really doesn't matter whether the point Q is on the first tangent line or the second tangent line. In both the cases, we will derive the same equation. So the locus of Q will essentially give us the joint equation of the two tangent lines together. So what will be the equation of the tangent using the 2-point form of equation of straight line? Well, we already know the point P whose coordinates are given as x sub 1 comma y sub 1, and now here is the variable point Q whose coordinates are assumed to be A comma B. So using these 2 points, can we come up with the equation of this first tangent line? Well, the equation is going to be like this. It would be y minus y sub 1 is equal to the slope, which is actually b minus y sub 1 over a minus x sub 1 times x minus x sub 1. That is the 2-point form of the equation of a straight line. So in this case, this is the equation of the tangent line where Q is located. And like I said, Q is a variable point. It could be located on the first tangent line or the second tangent line. In any case, we will get this equation for the equation of the tangent line. Now, if we cross multiply, I want to remove the denominator, then our equation going to look like this. Next, let's multiply the terms and let's get rid of the parenthesis. Then our equation going to look like this. And here you see the positive x sub 1 y sub 1. That term is present on both sides of the equation, so they will cancel out each other. Next, I am going to combine the y terms and the x terms together. I mean the y terms together and the x terms together. So the equation could look like this. And then I am going to bring everything onto the right hand side and make the left hand side 0. Then our equation will look like this. And as you can see, this is looking like the equation of a straight line. It is like ax plus by plus c equals 0. Here we have an x term, also we have a y term, and we have a constant term. Actually, there are two constant terms here, but we can combine them into a single constant term, right? Next, let's try to find out what would be the distance of this line from the center. Obviously, the distance of a tangent line from the center is actually the radius of the circle. So here I have noted that this line's distance from the center, which is C, located at negative g comma negative f, is equal to the radius of the circle. And then let's use the formula for the distance of a straight line from a given point. Using that formula, we can say that the distance of this line from the center will be like this. I have already created a separate video on this topic. I have shared the link in the description. Feel free to watch that video. All I am doing here is I am simply using that formula to find the distance of this line, the line that we just derived from the center whose coordinates are negative g comma negative f. And obviously this distance is equal to the radius of this circle. So we can write it as being equal to the radius of the circle, lowercase r. Next, let's cross multiply the denominator onto the right hand side, then our equation is going to look like this. And then to get rid of the absolute value sign and the square root, we can take a whole square on both sides of this equation. The left hand side would look like this and the right hand side will look like this. In the next step, I am simply going to get rid of the absolute value sign and the square root. So our equation could look like this. Now here, as you can see, we have the quantities a and b. They are actually variable quantities. They are nothing but the coordinates of the variable point Q. So to find the locus of the point Q, we have to replace a by x and b by y. Then we get the locus of a moving point. So here I have noted that for the locus of Q, let's replace a by x and b by y. Then the equation that we are going to obtain, that will actually represent the locus of the point Q. and that's the equation that we have been looking for, right? That is going to be the joint equation of the two tangent lines, because I took Q arbitrarily on one of the tangent lines, and if we can derive the locus of the point Q, that equation will be the joint equation of the tangent lines. So here I am going to replace a by x and b by y, then our equation would look like this. And in the next step we are going to expand the whole squares. The left hand side would look like this. It is like a squared plus b squared plus c squared plus 2ab plus 2bc plus 2ca. That is an expansion of a plus b plus c whole squared. And the right hand side could look like this. And then if we replace r squared with g squared plus f squared minus c, then the right hand side could look like this. In the next step, we are going to expand each of the terms on the left hand side. The first term could expand like this. Then the second and the third terms could expand like this. Then the fourth term could expand like this. And the fifth term could expand like this. And finally the sixth term could expand like this. And next I am going to expand the right hand side. The expanded form of the right hand side could look like this. Next I am going to cancel out some equal quantities on both sides of this equation. That is the first pair of terms that could cancel out each other. And then here is another pair of terms that will cancel out each other. And then here is another pair of terms that could cancel out each other. And then here is another pair of terms that will also cancel out each other. And here is again another pair of terms that would cancel out each other. And finally here is another pair of terms that would also cancel out each other. Next I am going to write down the remaining terms in a certain fashion. First I am going to note down the x squared times y sub 1 squared term. Next I am going to note down the 2 times x squared times y sub 1 times f term. Next I am going to bring this term from the right hand side to the left hand side. Next I am going to note down the y squared times x sub 1 squared term. Next I am going to note down 2y squared x sub 1 g term. Next I am going to bring this negative c y squared term onto the left hand side. And then I am going to note down 2x y sub 1 squared times g, this term. Next I am going to bring this negative term, which is 2x x sub 1 g squared, from right hand side to the left hand side. Next I am going to note down 2 y sub 1 g x f, that term. Next I am going to note down 2 x sub 1 squared y f, that term. Next I am going to note down 2 y g x sub 1 f term. And then I am going to bring this negative 2y y sub 1 f squared term onto the left hand side. And then I am going to bring this negative c x sub 1 squared onto the left hand side. And then I am going to bring this negative c y sub 1 squared onto the left hand side. And next I am going to bring this negative 2x x sub 1 y sub 1 term onto the right hand side. And then I am going to note down g squared x squared term onto the right hand side. And then I am going to note down g squared x sub 1 squared term onto the right hand side. And then I am going to note down f squared y squared term onto the right hand side. And then I am going to note down f squared y sub 1 squared term onto the right hand side. And then I am going to bring the negative 2x y sub 1 yg, that term onto the right hand side. And then I am going to bring the negative 2y x sub 1 y sub 1 g term onto the right hand side. Then I am going to bring the negative 2y g x f term onto the right hand side. And then I am going to bring the negative 2y sub 1 g x sub 1 f term onto the right hand side. And then I am going to bring negative 2xy x sub 1 f term onto the right hand side. You are probably not able to see the right hand side just because of the lack of space. I am not able to show you, but actually I have done it. So let me quickly scroll down and show you. This is how the left hand side and the right hand side terms looking like. I am leaving a lot of room there because I want to plug in some necessary terms on both sides of the equation. That way we can come up with some nice formula. We have a few more terms left. Let's take care of them. Next I am going to bring the negative 2x sub 1 f x y sub 1 term onto the right hand side. And then I am going to note down the positive 2x x sub 1 c term onto the right hand side. And next I am going to note down the 2y y sub 1 c term onto the right hand side. So with this we have noted down all the existing terms and we have rearranged them little bit. We kept some of them on the left hand side, we brought some of them to the right hand side, and similarly we brought a few terms from the right hand side to the left hand side, and I have done that on purpose and you will soon see why I am doing this. Now in the next step, let's plug in some necessary terms on both sides of the equation. So for example, here I am going to plug in one term on both sides of the equation, and that term looks like this, x squared times x sub 1 squared. So I am adding that term on both sides of the equation. That way our equation is still balanced. Next I have plugged in a term which is 2g x squared x sub 1. I have done that on both sides of the equation. Next I have plugged in a term which is y squared y sub 1 squared. I have done that on both sides of the equation. Next I have added a term which is 2f y sub 1 y squared on both sides of the equation. Next I have added this term which is 2g x x sub 1 squared on both sides of the equation. Next I have added this term which is 2x x sub 1 g squared on both sides of the equation. Next I have added 2 y sub 1 g x f term on both sides of the equation. Next I have added 2g x c term on both sides of the equation. Then I have added a term which is like 2f y y sub 1 squared on both sides, of course. Then I have added this term which is 2y g x sub 1 f on both sides. Then I have added 2y y sub 1 f squared on both sides. And then I have added 2fyc on both sides, and now I have added 2g x sub 1 c term on both sides, and I have added 2f y sub 1 c term on both sides, and I have added a c squared term on both sides now. So we are pretty much done adding the necessary terms on both sides of the equation. Now it's time to look at the group of terms. So let's start with the left hand side. On the left hand side, the group of first 5 terms could look like this. X squared is a common factor there, so if we take x squared out as a common factor, then we are going to be left with x sub 1 squared plus y sub 1 squared plus 2g x sub 1 plus 2f y sub 1 plus c. And if we look at the next 5 terms, there again we are going to see another nice pattern. We have y squared as a common factor, so if we take out the y squared as a common factor, then we are going to be left with x sub 1 squared plus y sub 1 squared plus 2g x sub 1 plus 2f y sub 1 plus c. And then if we look at the next 5 terms, there again we are going to see another nice pattern. We will have 2gx as a common factor, so the common factor out and the remaining terms going to look like this within the parenthesis. And then if you look at the next 5 terms, there again we are going to see 2fy as a common factor, and then if we take the common factor out, the remaining terms will look like this within the parenthesis. And finally, if we look at the remaining 5 terms, which is towards the end of the left hand side, you will see that c is a common factor, and if we take the common factor out, the remaining terms could look like this. Now one interesting thing you can see on the left hand side, that everywhere we have a nice big common factor there, right? Now let's arrange the terms on the right hand side also. The first 3 terms on the right hand side can be denoted like this as a whole squared, and then the next 3 terms can be denoted as a whole squared as well, and then the next 6 terms can be denoted as a whole squared, and then the next 4 terms can be denoted like this, and then the next 6 terms can be denoted like this, and finally the remaining 6 terms can be denoted like this. So now how is our left hand side looking like? Well, we have a nice factor there which is x sub 1 squared plus y sub 1 squared plus 2g x sub 1 plus 2f y sub 1 plus c. So on the left hand side we can take that as a common factor out, and then we are going to be left with just x squared plus y squared plus 2gx plus 2fy plus c, and that is our left hand side. So now the left hand side simplifies to something like this. Now let's look at the right hand side. In the right hand side, if you carefully look at it, you will see a pattern there. We have something like a s squared plus b squared plus c squared plus 2ab plus 2bc plus 2ca. Do you see that? So there we can write it as a whole squared then. So the right hand side could look like this. Those are the 3 big terms on the right hand side, and their whole squared will look like that. And if we remove the parenthesis on the right hand side, then our right hand side could look like this. So finally, we can rearrange the 2 factors on the left hand side like this, and we can write the equation in the final form. So this is the joint equation of the 2 tangent lines. Next, I am going to take a special case. When the center is located at the origin, g will be equal to 0, f will be equal to 0, and c will be equal to negative r squared. And if we substitute these values in this big equation, then our equation going to simplify like this. And that is the simplified form when the center of the circle is located at the origin. Now if you are thinking why I wrote c is equal to negative r squared, well, we know that r is equal to square root of g squared plus f squared minus c, and if we take a square on both sides, we can say r squared is equal to g squared plus f squared minus c. And then if we plug in the values of g and f as 0, because the center of the circle now assumed to be at the origin, then we are going to be left with r squared is equal to negative c, and of course from here we can say c is equal to negative r squared. So this is just a side note. So we have been able to derive the main formula here, which is nothing but the joint equation of the 2 tangent lines. Next, let's take an example. Let's suppose we have an example like this. It says find the equations of the tangents drawn from an external point P whose coordinates are 2, 3 onto the circle x squared plus y squared plus 6x plus 4y plus 8 equals 0. So let's get started with the solution. If we compare the given equation with the general form of the equation of a circle, then we can say 2gx is equal to 6x, and from here we get g equals 3, and similarly 2fy is equal to 4y, and from there we get f equals 2. And of course c is provided in the equation of the circle, which is the constant term, and that is equal to positive 8. Now what is x sub 1 and y sub 1? Well, x sub 1 is the x coordinate of the external point P, which is equal to positive 2, and y sub 1 is the y coordinate of the external point P, which is equal to positive 3 in this case. Next, we are going to use the joint equation of the tangent lines. We just derived it, so it looks like this. And here let's plug in the values. The first factor on the left hand side will look like this. That's essentially the given equation of the circle. And the second factor will look like this. Here I have plugged in the values of x sub 1, y sub 1, g, f and c. And the right hand side is going to look like this. There I have plugged in the values of x sub 1, y sub 1, g, f and c. Now let's try to simplify this equation. The first factor on the left hand side going to look like this, and the second factor on the left hand side simplifies to something like this, and the right hand side going to look like this, and then the left hand side is essentially going to look like this. The second factor on the left hand side actually equates to 45, so I have written as 45 times the first factor, and the right hand side actually simplifies to something like this, which can be written as 25 times x plus y plus 4 whole squared. I am taking out 5 as a common factor outside of the square. So 5 becomes 25, and then the remaining terms inside the bracket would be x plus y plus 4. And we have a whole square, of course. And now you see we have a nice common factor between both sides, 5. So let's divide both sides by a 5, then our equation could look like this. And in the next step, I am going to get rid of the parenthesis, then our equation would look like this. And then in the next step, I am going to bring all the terms to the left hand side, so our equation will look like this. And here we have a nice common factor again on all the terms. The factor is positive 2, so if we divide this equation by 2, then we are going to get something like this. And in the next step, I am going to reorganize the terms in such a way that it looks like a quadratic equation in x. So now this equation looks like a quadratic equation in x, and from here we are going to use the quadratic formula to find the value of x. So we can say x will be equal to negative b, which is negative of the coefficient of x term, then plus or minus square root of b squared minus 4ac, and divided by 2 times the coefficient of the x squared term, that is the 2a. So that's as per the quadratic formula, it is actually negative b plus or minus square root of b squared minus 4ac over 2a. That's exactly what I have done here. And if we simplify the right hand side, it's going to look like this. And then let's simplify the terms inside the square root. And then the terms inside the square root actually a whole square there. So the right hand side could be written like this. And then finally we can say that x is equal to something like this. And if we multiply 4 on both sides, then we get rid of the denominator on the right hand side. So then 4x will be equal to something like this. And from here we are going to write down two equations. Taking the positive sign, we have the first equation here, and then taking the negative sign, we have the second equation here. And if we solve them, the left hand side equation will look like this, and the right hand side equation will look like this. And from here the left hand side equation simplifies to something like this, and the right hand side equation simplifies to something like this. And if we remove the common factors, then the left hand side equation looks like this, x minus 2y plus 4 equals 0. And the right hand side equation looks like 2x minus y minus 1 equals 0. And those are the equations of the two tangent lines. Here you have seen how I have converted the main equation into a quadratic in x. We could have done it the other way also. We could have converted it into a quadratic equation in y, and then we could have solved for the value of y. In either cases, you will end up with the exact same equations. You can try it converting into the quadratic equation in y, and you can try to solve it by yourself, and ultimately you will end up in the exact same two equations for the tangent lines. I hope all the steps made sense. Thank you for watching. See you in the next video.